Look at transformation. Yesterday, the transformation, you look at translation, left and right, up and down. All right? Today is going to be slightly different. We're going to look at reflection and dilation. And tomorrow, the last lesson will be combining everything. All right? So, like I said, depending how much time I have in terms of going through the test with you, tomorrow there is a worksheet that you can do to actually learn how to combine everything. All right? So now we're just looking at reflection and dilation. So by the end of the lesson, you should know how to dilate a function parallel to an axis. Could be the x or could be the y-axis. And then you should be able to generalize and describe the transformation of A into fx and f into bx. All right? So those are the two that's important. Yesterday, we looked at something else. We looked at what you call C and D. So yesterday, we looked at f, oops, what have I done there? We looked at f x plus c or f x plus d. All right? So those are the translation that we looked at yesterday. Today, we are looking at reflection and transformation. Okay, next thing, you should be able to solve, again, algebraic problems involving dilation, mainly to look at the new equation or look at how you transform. I should not use move, how you transform the parabola and then recognize the condition of reflection about the axis. All right, the one thing that I've had a chat with Mr. Alfonsi this morning, we were talking about moving left or right, up and down. Those are all relative. So I would prefer in the exam, if you're asked to describe, is translate in the positive x direction, positive x-axis, or translate in the negative x-axis.
And after that, you put like by how many units?
Yeah, by how many units, definitely. You don't really, try not to think about left and right, it's relative. Okay, here, if I face you, this is your left, but it's my right. All right, so that's the reason why we try to avoid that, although a lot of book users translate left and right. Okay, now, so let's have a look at translation this time. In terms of, not translation, we're looking at dilation and reflection. Dilation is either expanding or dilating it to the parallel to the x-axis or parallel to the y-axis. All right, two things you need to know. This is parallel to the x-axis. This is parallel to the y-axis. All right. Okay. Could be moving up or moving down. This could be moving in or moving out. All right, two things that you need to know. I am coming to that bit in a few minutes. All right. There is a way of doing it, and then you've got to follow it. This is like step by step. This is really like recipe, cookbook, step by step. Once you can do it step by step, it's going to make life a lot easier. Now, yep. So here, horizontal dilation. Horizontal dilation, we put in f equals to bx. Now, the dilation parallel to the x-axis, the factor is 1 over b. So if it is from f of x to f of 2x, what you do is you multiply the x coordinate by half. All right? Reason.
No factor.
Sorry? Not now factor law. Reason. This is back. All right. So the transformation of f of bx generalizes a dilation parallel to the x-axis. Factor of 1 over b. I will give you an easier way of remembering all this a little bit later. So bear with me for a little while. Okay? So this one is called stretched horizontally. Not that I really like the word stretch horizontally, but it's a good way of describing it. So when you think about it, it's making it wider or narrower. All right, can I move on to the next bit? Yeah, if you're fine, I'll move on. Looking at a concept of speed and time. So if we go to fx, from fx to 2x, yeah, sorry. Now, think about it. Why we use 1 over b? So if we go from fx to f2x, the x-axis is actually speeding up by a factor of 2, right? So you can think about it as if I draw something like this. Y and x. So I go up there, all right? So this time, instead of x, let's say this is 1. Right, I want to dilate it. Okay. I am doubling the speed of x. All right. So if I double it by a factor of 2, and let's say that's 1 second, and then to reach the same point is actually half of a second, correct? Yeah? So therefore, let's do this, half of a second, half. So therefore, you can see that it is actually, use a different color, move, dilate by a factor of half. That's the reason why this is the only one which is not intuitive. All right? Anything to do with the x, like when you're translating, is not intuitive as well. This one is not. So when you talk about horizontal dilation, you are actually making the, if it is parabola, narrower. All right? So remember, dilation factor is 1 over b for horizontal. Then horizontal reflection. It only happens when there's a minus b. So what you do is you dilate first. Once you dilate, you can reflect about the y-axis. Once you dilate, so here, if I sketch it for you again, all right, this is the original. Oh, actually, y and x. This is original. All right, let's use a critical point here. X and y. What you've done is with minus b, let's say it's 2. Let's put x in here. Is x over b and y. All right, same point. So you can actually sketch it that way. All right? So this is the first step. You dilate it. And then, because it's a reflection, you know that the distance here is the same as distance here. Which means your y is still the same, but your x over b is now minus x over b. All right, so use a different color. This is minus x over b and y. So you can draw that up. So this is how you sketch it, step by step. You start off with dilation and then reflection. Now, because it's minus b, you can do it if you want to reflect first and then dilate. I don't mind. Personally, for me, I prefer to dilate first, then I know the coordinate, and then I reflect to the other side. Got it? It's a lot easier to see it, in my opinion. A lot easier to see it that way. But again, some of you might prefer to reflect it first and then dilate it. It's up to you. My advice, dilate and then reflect. To me, it's more logical, it's easier to observe. Got it? Yeah? Everybody happy with that? So later I'll do some example. So here, if we are asked to describe the transformation that have occurred from fx to f minus 3x. First, you know that this is actually dilation, dilating by a factor of 1/3. So I can write down dilation, or you can say dilate by a factor of 1/3. Dilation it should be parallel to x-axis by a factor of 1/3. All right? So if it is negative, it's the same as well. Multiply the negative x by a factor of 1/3. Right? So then reflection. Reflect about the y-axis. All right? So you start off with something like minus 3x. Oh, well, it's start off with, could be something like this. All right? The fx could be something like this. And then you dilate it, and then you reflect it. All right? So I will say this is step 1, which is the original. Step 1, dilate. And this is reflect. All right? So does that make sense, D and R? So the next one, think about it. If fx is 2x squared minus 3, and you are dilating into gx, 2 half x squared minus 3. So how would you describe that? Can you describe that for me, please? Yep.
Factor of 4. Oh, 4.
Think about it first. You are now substituting x with half x. All right? So here you are saying that the dilation. Now, the thing to look at is the half x in there, in the bracket, yes?
Oh, wouldn't it be dilated like -1? Because of like you flip.
No. What the dilation factor is 1. Oh, yes, Luke? Yes, 2. Because it's 1 over b. All right. 1 over half is 2. So think about it. This is going to be wider. So dilation. Okay, I'm going to show you 2 ways of writing. Here you can just say dilation parallel, or if you like, you can just say dilate. Dilate parallel to x-axis by a factor of 2. That's it. Is there any other changes? No. The change is the x. All right? You're substituting x with half a x. It's inside the bracket. All right? Later we'll look at if there's an a outside there when you are multiplying the factor. Yes?
Why wouldn't it be factor of 4 since this goes from 2x squared to
We are not looking at the square. We are looking at whatever happens inside. Look at whatever is happening inside. Don't look at the square outside. You are still using the same parabola, but then you are applying a dilation factor. Yep.
Wait, so with dilation, is it like 1 over 3? I'm quite confused. Is the reason
Okay.
is x squared? Is it
No. This is just a function. You are not given a function. You don't know what the function is.
Yeah.
This one, you don't know what the function is. You only know that you have changed the function to f equals to minus 3x. Therefore, I sort of use half a parabola to show you.
So if you're saying
Alright.
The dilation factor is b, would that be -3 over 1? So then
No, that negative is a reflection. Next bit. So this is the dilation. All right, let's do this. This is the dilation 3. All right, this is dilation. It's a 3x. Look at 3x. All right, and then this is the minus. Looking at the reflection. All right, does that make it clearer?
yeah.
Yeah? This is a lot of practice, that's all. Once you practice it, it's like I say, cookbook recipe. Then you've got to apply it to some other situation. Any question before I move on? Happy? Parabola is not a really good way of explaining it. That's why that's why I use half a parabola.
I thought it
All
would
right.
be the reflection about the x-axis then, because it's negative, so it would be going from, say, a concave up to a concave down.
It's different. That is when you bring the negative out. This is within the x itself. All right, you're substituting x squared with half x or minus half x rather than changing. All right, so let me pause this for a while. Use this one as a guide. Make sure that you know your horizontal dilation, your horizontal reflection, your vertical dilation, your vertical reflection. So the way I see it, horizontal reflection is if you can see your palm, if you cannot see your palm. All right? So it's here, horizontal. The other one, you're moving. Let's say this, your elbow joint here is the origin. You are flipping up and down. Does it make it better, easier? Understand? All right, I'm going to stop here now. Now, so you can see the purple line. Minus 2fx, you are reflecting about the x-axis. So this point here will come all the way. Oh. All right. So next bit. Please listen. Dilation is not moving it's not like add or subtract. Dilation is moving every.
You haven't multiplied it by 3.
True, multiplied by 2. Oh, sorry, it's my fault. Yeah, okay. All right, multiply by 2 is 3 and 3. Yep, that's point. Sorry, it's my fault.
Yeah, I got confused because
Got it. I know what I've done wrong. All right, let's start again. I multiplied by 3. All right, let's start again. Thank you. So this point will go up there. This point will go down here. This point will go up there. That's correct. And this point will come down here. Yep. So if I sketch it, so the shape changes completely. All right. So this is y equals to 2fx. Yep. Sorry, I made a mistake. It's very easy to make a mistake. Shh. So the next one, you are reflecting this point will come all the way down here. Yeah, like I say, you are moving your arms up and down. All right. Think about this reflection, and the other reflection is your palms down and palm up. All right. So here you've got that. This point will go up to here. This point will go up to here. This point will come all the way down to here. And then this point will go all the way up to there. So it just basically looks like this. All right. So there's reflection about the x-axis.
I think this should be at 2, sir, because -2 times negative. You want to go only with 3 units.
Sorry, my fault again. I was just looking at the negative. All right. So what I've done is, listen, my fault again. Number 2, I've talk about. I should have just reflected the 2fx rather than reflected the fx. So the blue one is actually y equals to minus fx. All right, it's my fault. So this is minus fx. Y equals to minus fx. In fact, if I do y equals to minus 2fx, it should be reflecting just this, the purple line. So it will come all the way down here, purple line. This one will come all the way, go all the way up here. And this will come all the way down here. And this will go all the way up there. All right? So this is how you do it. All right, it's my fault. So this is y equals to minus 2 f of x. All right, please listen. I know that I've made a mistake in terms of drawing the blue line. You better get 100% the test. I'm serious. All right, I know I made a mistake, but you still need to listen. Here, what I've done is I really neglected the minus 2x. I just basically drew the fx. But you can see that the process is still the same. I reflected that first, and then I applied the dilation factor. All right? You can see the process. Even when I made a mistake, I know that I've reflected it and I applied the dilation factor. It's up to you. My preference normally is I like to dilate and then apply the reflection. All right? So this is what you need to know. And